Let's talk about subnetting. So subnetting is important in networking. You hear about it all the time. You hear even people perhaps freaking out. I know I freaked out when I heard that I had to do it for exams like Network Plus or CCNA. And I feel like there are a lot of complicated methods out there for subnetting, but there was a method that was shown to me middle of my career and it just blew my mind. It's really fast subnetting method. And I really want to break down for you what subnetting is, why we do it, and then show you the methodology behind it. So if we want to talk about subnetting, if we just come in here and just do an ifconfig, and we look at our IP address, right? We have our inet, which is our IPv4. And you can see here too, we have this net mask. This is also known as a subnet mask or a subnet. And it just says 255.255.255.0. Doesn't really tell us a lot if we don't know much about it, but this is what a subnet looks like. And we can think of subnets in ones and zeros. It's all bits, right? So we've got 8 bits here, just like an IP address, IPv4, same thing. 8 bits, 8 bits, 8 bits, and another 8 bits. And we've got ones and zeros. If all the ones are switched on, we've got 255. If none of the ones are switched on, we've got 0. And depending on how those ones and zeros are switched on or off determines a lot of things for us. And that's why this net mask is important. Now, attached to your resources for this course, I've created an Excel sheet that I think will be useful. So if we look at the Excel sheet, here is the CyberMentor's subnetting sheet. And let's talk through this. It looks like a bunch of numbers and it might look crazy for you. And we're going to talk about how this breaks down, how the bits break down, and then how I would write this shorthanded for an exam or a test or just something that I do on a day-to-day basis. So first, let's talk about the bits. So come to the bits tab here, and we have our 8 bits, right? We can count this across, and there's 8 here on the count, and you can see that. And it starts with 128 and descends down to 1. You just keep cutting it in half, right? So 128, 64, 32, 16, 8, whatever. What's more important is why we get to these numbers. So if we have a 1 switched on here, it adds to the value. When all the ones are switched on, it equals to 255. You see all the ones switched on here. If we were to highlight over all this, come down to the sum, you see the sum is 255. That's all this formula is doing here. So if we were to come through and you see all the zeros here, nothing's flipped on to actually turn any value on here. How this actually works is the switch has to be on in order, right? So if we were to switch on another bit, we'd have to switch it on here. And we'd have to switch another one on here. We couldn't just come down here and switch it on here. It wouldn't make sense. It doesn't work that way, not with subnetting. So we're going to take these back off and just show zeros again. But you see how the values change. If, for example, we had this network and you saw the default, and I'm showing you the 255, 255, 2550, this standard here, because that is what's known as a /24 network. That's very common. And it's very common because it's used mostly in households and small businesses. And it's done this way because of the amount of hosts that it allows. Now, if we talk about the host, you can see that I have here 2 to the 8th power. Why do I have that? Well, we actually go by how many bits are switched off or how many hosts are available to us. So if a host here or a bit was switched on, then we lose the amount of hosts we have available to us. And this subnet gets smaller and smaller. Now, don't worry too much about the ones and zeros. It's going to make a lot more sense when we stop talking in these binary terms. I just kind of want to break down the math behind it first before we make it really simplistic. So again, we're talking about what's called this /24 or WAC24 network. And it's so standard because of the host. Again, 256. Think of all the devices in your house. You have cell phones, you probably have computers, you might have like a Roku or Amazon Fire or something along those lines. You might have smart TVs or smart watches or something that connects to the internet. Well, again, they're all connecting through NAT, right, and going out, but the amount of hosts that you can have on your private network really depends on this subnet mask and how you set it. So we have this class C that you saw before, the 192.168.1 or .0 or however you want to have it, right? Well, it allows us to have 256 when we have a subnet of /24. So that's very common for a household. It's also common for a small business. Maybe there's a printer, some few devices in there, but they're never going to get over this 256 hosts. Okay, so when we come to the subnet cheat sheet, let's break this down a little bit differently. So we have our host here. Let's start with the /24 where we just were. And you saw that there is 256 available hosts as we start turning off bits. Okay, we turn off a bit here, we turn off a bit, keep going down the list. The hosts start getting bigger, and that just corresponds here. We have a /24, and the only reason I'm saying 24 is I'm counting the ones across, right? So we got 24 bits switched on. If we had 23, okay, it gets bigger and bigger and bigger. Now, let's stay away from the ones and zeros. I think it's a little bit complicated. The better way to think about this is to look at the subnet mask down here. And I'm going to replicate this, and then we're going to come back to it. So what I do here is we can have a possibility of 32 bits switched on, right? So I'm just making a new tab, and I'm just going to go over here, and I'm going to hit Control and drag this across till it hits 8. Okay, and then I'm going to do the same thing with 9. I'm going to drag it across. All I'm doing is just making, really quickly, 32 placeholders. And I'm just emulating here if we had the possibility of 32 different switched on bits. So imagine one bit is switched on, imagine all 32 bits are switched on. That's the possibilities here, right? So always, for sure, we're gonna have an amount of hosts, and we're gonna have a subnet mask, okay? So we'll just call it subnet there. We always start here with 128, just like the bits that you saw. You saw the 128 start on the bits. Let's just start also with 128. Now, as you saw, every bit that's switched on, remember when we switch a bit on over here, it starts decreasing. So we're going to decrease for the bits that are switched on. 64, 32, 16, 8, 4, 2, 1. You come over here, and what I like to actually do is I like to just add these numbers together. And you can see 128 and 64 is 192. And then you can add these two together. So you get 192, 32. You just add diagonally is the way I actually always do it. So 224, 240, 248, 252, 254, and 255. Now, what does that correspond to? It corresponds to the possibilities of the bits being flipped on, right? So this looks just like what you see here. Same deal. And if you had a 1 underneath of it, okay, then you got 128. If you've got another 1 underneath of it, well, guess what? You've got 128 plus 64, which is 192. And this number keeps growing. Why is this important? This is still all ones and zeros, right? Well, let's start thinking about it. If we have a /24 network, we've got 24 bits turned on. Our subnet mask is 255.255.255.0. If we had a /16, it becomes 255.255.0.0. Why? Where are these changes coming from? Let me show you this. Okay, for a /8, I'm just tying this into just this right here. Well, this is coming from the number of bits that are turned on. 8 bits turned on, we've got 255, and the rest are zeros. You got another 8 bits turned on, 255, 255, the rest are zeros. Come down to this /24, which is that really common subnet that you see, and you've got 255, 255, 255, 0. Now, this is very common, okay? Let's go back to the cheat sheet now. And you can see that I've got X as a placeholder in the subnet. So what I'm saying here is you look at this list and you say, I've got a /1. Well, for this whole area here from 1 to 8, the placeholder is going to hold in place of this X. So for a /1, if I've got 128, then guess what? It's going to become 128.0.0.0 because that's how it would be. And if you turned on just one bit here and made all of these zeros, guess what? Just the 128 would be on, the rest would be zeros. Okay, if we had a /14, okay, so 255's automatically flipped on. You have a /8 already, you passed through it. Okay, so you're starting on the second iteration here. /14 corresponds down here to 252. So you'd have a 255.252.0.0. So all this is placeholders. Let's go back to the sheet here. So I make this quick and dirty list. This is what I write out when I'm just writing out something quick for an exam. I'll write out 1 through 32. I'll put the host here and I'll put the subnet here. So again, if we know that once we cross through 8, 16, 24, 32, that has a 255 in front of it, all we've got to do then is we'll say /27. Well, we've come through 3 columns. Then I know for sure that we've got 255.255.255. something, right? You see the /27, you come down here, the subnet would be 224. Say 28. Okay, 255, 255, 255. Look at the 28, you've got a .240. And this is going to be confusing. Subnetting's not necessarily easy. Once you get the chart down, it makes a lot more sense. So let's start piecing some more things together. When I say that I've got host, now the hosts that I'm showing you only correspond to these first rows, but it's very common or very useful just to know this number right off the bat. Now, if you look at the cheat sheet, what you can do here is you just know that you start with a 1 or you start with the 128 and you go down, but every time you go up, you're doubling. And why are we doubling? Do you remember from the bits part? Every time a bit is turned off, so as we go up a number, we take it to the next power. So we've got 8 bits turned off. We take 2 to the 8th power, it's 256. Well, here you go. Look, come through here, 256. We go to the 9th power, 512, to the 10th power, 1024. It just keeps doubling, okay? That's all you got to think about in your mind, is it keeps doubling. So on an exam, for example, you might have something like, how many hosts could be potentially in a /20 network? And you come to your cheat sheet that you made or you have in your head and you say, well, 496, and then we'll get to this in a minute, but we have to subtract 2. So 494 potential. And why is this all important? What do we even care about any of this? Why am I rambling on? Well, you need to know based on the network. Okay, the /24 is great for a small office, home network, however you want to have it. But what if you're a large enterprise? Maybe you have thousands of devices, okay? Maybe you want a /16 network. That might make more sense for you. Or you even see some with a /8 network. It just depends on how big the company is. The larger the company, the greater chance that you're going to see that they're not using /24. Or they could even have subnetted segments of their network where, say, they have just telephones and they've got 500 employees and 500 telephones. They might just have one /23 network for nothing but telephones because that's the amount of hosts that fit in there. So what we're after with subnetting is how many hosts can we fit and what is the mask that's behind it? So those are questions you might be asked in an exam, and these are questions that you're just going to see. And when you're given addresses, say you're doing a pen test for a client, you might be given something like this. You might be given an IP address, 192.168.1.0/24. Okay, and immediately in your head, you're like, oh, /24, that's standard. There could be up to 256 hosts or 254 hosts or devices in this network. But if they gave you something like 192.168.1.0/20, then you might look at your little chart and say 4,094 hosts. Remember, we're going to subtract 2. 4,094 hosts in this network. Now I know if I'm scanning this, I'm up against a lot more devices potentially than I am in this. Okay, so when a client gives you your subnets, they might just write it out like this. And depending how big your client is, might depend on how big their subnets are for you. For example, I just pen tested a client that was a /16 all the way across. And it looks something like 10.1.0.0/16. Okay, and your subnet mask for that would be something like 255.255.0.0. And how does this come into play? Well, every time you have a 255, that number's locked in place. That's another way to think about this. So that 10 is always locked down. This 1 is always locked down. The rest of the bits are fair game. Meaning we could have 10.1.1.0.1.2.3. We could actually have a 0 here. 0.1.2.3.4. And that's how this number for like a /16 gets so big. Because you have 10.1.0.0 through 255 on the possibilities, which equals 256 hosts. Okay, for one range, you get 256. Well, imagine you have to do that 255 other times, right? And that number gets substantially bigger here. And then if you were to have a /8, then of course it gets bigger and bigger. So what you need to realize are a few things here. We have these addresses, and you see the /1, /8. Again, we call them WACs. WAC 24 is going to be very common. I would say WAC 16 is probably your next common. You might see some weird subnetted networks like this, but typically it's /24, /16. Now, your network ID is typically what is known as your first address, and your broadcast ID is known as your last address. This is not always the case, but it is very common. And let me log back into this Kali machine here and I'll show you. So we have our IP address, 192.168.57.139. And we've got a net mask of 255.255.255.0. What does that tell you from what we just learned? That tells you we have a /24 network. Okay, this is a common network. There are potentially 254 hosts. Why do I keep saying that? Why do I keep subtracting 2? Well, we've got a network ID and a broadcast ID, or broadcast IP here. Well, what we need to know is we are .139. We could be anywhere from .1 to .254 within this network. That's our 254 possibilities. This 0 means we have the flexibility to be any IP address range from 1 to 254. Usually a .0 for this IP here and a .255 make up your network ID and your broadcast IP, okay, usually. So if we were to say something along the lines of, let's go back to this Excel document, and we were to say something along the lines of this. Let's say that we have a /24 network, and we want to know how many hosts. We want to know what our network ID is and what our broadcast ID is, or IP is, okay? We would say, okay, and we'll give it one more. We'll say it's a /24, and the IP starts with 192.168.1.0, okay? Or we can even write it like this, 192.168.1.0 /24, delete this, and we'll say, what's our subnet mask? What's our host? What's our network? What's our broadcast? So subnet, you come to your cheat sheet, you say, okay, /24, I already know that I need to be filling in this area here on the X, so I'm just gonna come in 255, what's the X? Well, we know to come down this row, 255 here, .0. Okay, and then we've got hosts, so I'm just gonna expand this a little bit. We've got the hosts, okay, hosts are right here, 256 hosts. Potentially 254 though, because we always subtract 2 from the host total. So our network ID is usually the first address available to us, which is 192.168.1.0. The broadcast is 192.168.1.255, meaning available to us is anything from .1 to .254. Let's take a look at something else. That's a basic example. Let's do like a /28. Let's say we got 192.168.1.0 /28. Now what? Well, we've got 16 hosts here. Okay, so our subnet is then going to fill in 255.255.255.x, right? Because we're in this row. /28 says it's going to be a 240 when we drop down to the subnet mask. I'm going to make this a little bigger. How many hosts? 16 minus 2. We have 14 hosts. Okay, so the first non-host would be 192.168.1.0. Again, still the same thing. First address. Last address is going to be what? 192.168.1.15. Does that make sense? 0 to 15 is 16 addresses. Usable space is 14 because we take out the network and the broadcast. Now, you could see something like this, and then guess what? You're segmented. So because you're only using this little bit of space, you can then in turn have something like this, 192.168.1.16 /28. And then it starts the same way. Your subnet mask is actually the same because you're using a /28. You come through, you can just copy and paste that. The hosts are still the same. What changes here? Well, your first address, 192.168.1.16. and then your last address, which is 192.168.1.31. So because this is smaller on the /28 side, we can actually have multiple networks within, like, say, a .1, .0, .1, .16, .1, .32. You get multiple little networks here with only a small amount of hosts. So maybe you have just a few servers in this range, and you have like servers A, B, and C. They go in a /28, and then you have another one of servers D, C, and E, or D, E, and F, however you want to say it. And you have more in that range. Okay, so you can subnet this out into different things. And when we see subnets, we see all kinds of stuff. We could see phones, servers, user computers, wireless, all different sort of things. Some companies get really specific with their subnetting. Now let's try one more. Let's say we have a /23. Now I want to put in 192.168.1.0/23, but that would be wrong. Why would this be wrong? This is actually going to be a 0, and I'll show you why in a second. So we're no longer locking in this number anymore, right? When we get below the /24, the 255 all the way across for 3 of them, guess what? We're now have the ability to change this number other than what's locked in. So let's do a .0. We'll talk about why. Let's hit enter here. So a subnet on a /23. Well, we're going to do a 254, which is going to be the placeholder of the X here. We're going to come in and say 255, 255, 254.0. And now again, we're not locked in. So remember, this 255 would lock in this .1. That doesn't happen anymore. So we've got 255, 255, 254.0. We're actually going to start at 0 here. And we're going to say the number of hosts that are possible, it's 510. Okay, 512 minus 2. We'll say our network ID is 192.168.0.0. And our broadcast would then be 192.168.1.255. Why? Okay, so we have the possibility now that we're spanning 2 ranges. We've got 510 hosts in this network. Okay, and we have the ability to go between 0 and 1. We've got 2 options now, 0 and 1. So if we were to say another network, if we wanted to get to like a 2, we'd actually have to say 192.168.2.0/23. It would be the same subnet mask, same number of hosts, but then this would be 192.168.2.0, 192.168.3.255. Again, there's 510 possible hosts in between this, right? Because you got to think, .0.1, .0.2, .0.3, all the way through 254. And again, 1.1, 1.2, all the way through 254. So that equals 510. Once you've hit that maximum, that 1.255, then guess what? You start at 2, you have a whole new network here. Just like these smaller segments, you get whole new networks on the bigger side as well. So what you need to know is that if I were to put something like a 192.168.1.0/23, that would have fallen into line with the 1 and the 0, and our actual network ID still would have been 0.0, and a 1.255 would have been the broadcast here. And you can double check this. Anytime you're confused, you can double check your CIDR notation. So I'm going to bring over a website that I will show you here. And this is just an IP addressing guide. It's called ipaddressguide.com. You bring this over and you scroll down just a little bit, and I just put in 192.168.1.0/23, and you can see that it actually corrects me and says the first bit is 192.168.0.0, the last one's 192.168.1.255. Total host is 512 minus 2. Shows you that, again, first IP, last IP, you got your net mask. Very easy to use a CIDR calculator here, or an IP range to convert to CIDR as well. So very useful calculators, but if you're not allowed to use these for like an exam purpose or something along those lines, then using the cheat sheet that I've shown you is super useful. Now, what I want to do is I want to try 3 more subnets. Okay, I'm going to write these out. I'm going to say 192.168.0.0/22, 192.168.1.0/26, and 192.168.1.0/27. I want you to solve these for me. Tell me the subnet mask, the host, network, and broadcast. And with that being said, this again is a very complicated topic. I did not pick this up the first time or the second time that I got it. If you're running confused right now, perfectly normal. You can go back and watch this video again, try to pick up more topics, try to understand it. Maybe I'm not the right instructor for this either. I do recommend looking at other resources to completely fill in your knowledge gap if there is one that exists. Another resource that I'll link down is what is called 7-second subnetting. It is very useful. A lot of students have recommended it to me. I'm going to push it forward as well. So go ahead and try to solve this. Understand that what you're after here is just understanding what a subnet is. Okay, when you see something like this, if a client sends you 192.168.1.0/24, you're going to say, hey, okay, I know that there's probably 254 hosts in that network, and I know what I'm working with. If you see this 255.255.255.0, again, you know that you're working with a /24 network. Very standard stuff. That's what we're after. I don't expect you to ever memorize this. I don't have this memorized. Like, I don't come in here and say, you know, a /18 is a 255.255.192.0 network, and it's got 16,384 hosts. I don't do that. Okay, I have a cheat sheet. I'll use a website if I need to. For the most part, what you need to understand is 254 hosts for a /24. If that number has gone up to like a /28, you know you're dealing with less. If that number is lower, like a /16, you know you're dealing with a bigger network. That's really what it comes down to, unless you are working in networking, and then these become more important. But as a pen tester, understanding how to read this, understanding what the subnet is, and just identifying it with very basic measures, this is extremely useful. So I will catch you over in the next video when we talk about solving these challenges, and hopefully we got them all right. So I'll see you over there in the next one.